Hi class, in this video we are going to review how to put an equation in Sturm-Liouville form so that we can solve it as an eigenvalue problem. First, let's review what Sturm-Liouville form is. Sturm-Liouville form is when the equation is of the form shown here, where we have y prime of x times p of x prime plus q of x times y of x plus lambda times w of x times y of x equals 0, where w is the weighting function and lambda is the eigenvalue. These go with a given set of boundary conditions, which are shown here. We write it as a is less than or equal to x, which is less than or equal to b. So x is defined on our range a to b. Then we have this set of boundary conditions here, which state that alpha times y of a plus beta times y prime of a equals 0, and delta times y of b plus gamma times y prime of b equals 0. Alpha, beta, gamma, and delta can be any constants. Once we have our equation in this form, we can solve for all of the eigenvalues and the eigenfunctions of this equation. And more importantly, we can rewrite another function as an expansion of our eigenfunctions by writing it in this form here, where a of n is equal to the inner product of y and phi of n divided by the inner product of phi of n times phi of n. Phi of n here are our eigenfunctions corresponding to our eigenvalues lambda n's. And just note the inner product is defined here. It is the integral from a to b of f of x times g of x times the weighting function. So this is where our weighting function becomes important. Now we are going to look at an example that is already in Sturm-Liouville form, and then we will look at an equation that is not in Sturm-Liouville form, and we will work through how to put the equation into Sturm-Liouville form. First, we have this equation, which is y prime prime plus lambda times y equals 0. Let's rewrite what Sturm-Liouville form equation is. Here we have y prime times p prime plus q of y plus lambda times w times y equals 0. If we expand this part right here, the derivative of y prime times p, using the chain rule, we get y prime prime times p plus y prime times p prime. Now we can relate the equation we had up here to this expanded Sturm-Liouville form equation, and we see if we compare our y prime portion with the y prime prime times p, our p must equal 1. And if we compare the lambda times w times y to our lambda times y, we see the weighting function must also be 1, and q of x must equal 0. Now we are going to go into a more complicated example where we are given an equation not in Sturm-Liouville form, and we must put it in Sturm-Liouville form. Our equation is the following: y prime prime plus 2 times y prime plus lambda times y equals 0. I have rewritten Sturm-Liouville here just so we can visually compare them. And I have also written the expanded Sturm-Liouville equation right here. The method to putting an equation that is not in Sturm-Liouville form into Sturm-Liouville form is multiplying our equation by an integrating factor. Here we multiply the entire equation by sigma, an integrating factor. So we get sigma y prime prime plus sigma 2y prime plus sigma lambda y equals 0. We then compare this to our expanded Sturm-Liouville form, where we have y prime prime times p plus y prime times p prime plus q times y plus lambda times y times w equals 0. If we line up the two portions where we have y prime primes, we see that sigma must equal p. We can then also line up the two parts of our equation that have just y prime, and we see that 2 times sigma must equal p prime. Since p is equal to sigma, p prime is equal to sigma prime, and we can substitute that into our equation over here. We then get 2 times sigma equals sigma prime x. Solving this as an ordinary differential equation and using separation of variables, we arrive at the equation sigma of x equals e to the 2x. Finally, we have arrived at this point where we have sigma of x equals e to the 2x. Since sigma of x equals p of x in this example, p of x equals e to the 2x, w of x must also equal e to the 2x because we multiplied the entire equation by our sigma, our integrating factor, and q of x is still equal to 0. This is our equation in Sturm-Liouville form, and we can now solve for the eigenvalues and eigenfunctions of this equation.